This is planning of experiment from 2018 session. The first one is from March 2018 paper. The magnesium react with sulfuric acid at room temperature to form a hydrogen gas. We have to plan an experiment to find the rate of a reaction between a magnesium ribbon and sulfuric acid. So whenever metal react with acid, it gives salt and hydrogen gas. So either we can measure the volume of a gas given off in a unit time or change in the mass in a particular time interval. We can work out the rate of reaction. In your answer, you have to include a diagram. So it's up to you. If you want to measure the change in mass, then we have a conical flask in which we have sulfuric acid and there's a cotton, so that the content in the flask does not escape, only the gas will escape, and we will keep it on the balance. This is one way. Or the second way, instead of measuring the mass, we can connect a gas syringe, place a bung and connect a gas syringe here. To measure the gas given off. What else we need? Because we want to measure the rate of the reaction, so we want to measure the time. So we should have a stopwatch or a stop clock here. So what are the steps to carry out this reaction? This will be the apparatus. Indicate how you would use your result to obtain the rate of reaction. So how we can measure the rate of reaction also? Like first we'll take 10 cm cube of sulfuric acid. By measuring cylinder, then we will add to conical flask. Then we will add a known mass of a magnesium. And connect gas syringe to measure the volume of gas for example, 30-second interval for 3 minutes. Then we'll sketch a graph between volume of the gas on y-axis and time on x-axis, and find the gradient which shows the rate of reaction. So we can work out the rate of reaction by finding the gradient. Specific experiment from summer 2018 paper. Potassium chloride is a salt which dissolves in water. The solubility of a salt is a mass of a salt that dissolves in 100 cm cube of water at a particular temperature. Plan an investigation to determine the solubility of a potassium chloride in water at 40 degrees centigrade. You are provided with the potassium chloride and the common lab apparatus. So what we will do, we'll take like example, as we want to find how much potassium chloride can dissolve in 100 cm cube. So we can do it for 10 cm cube, and then 100 cm cube, it will be 10 times the solubility, or you can take directly the 100 cm cube of water. So first we'll take 100 cm cube of water by the help of a measuring cylinder. Then we will heat the water to 40 degrees centigrade and try to maintain this temperature and add potassium chloride until no more will dissolve. Because solubility means how much mass dissolve in particular volume, that is a solubility. And then we'll filter to remove undissolved or insoluble solute. Then we want to find how much dissolved, so we will evaporate all the liquid and measure the mass of a solid. Or there's also another way is there, like initially we measure the mass of a solute and we add and filter the undissolved one, and we take a difference of the two masses to know how much is dissolved. So how we can carry out this experiment, we'll take 100 cm cube or 10 cm cube of water by measuring cylinder. Then we will add potassium chloride, KCl, by the help of spatula. After that, we will stir. Then we will filter to remove undissolved KCl, potassium chloride. Then we will evaporate the water. Then we will measure the mass of residue. Then solubility will be equals to mass divided by volume. So this is how we work out the solubility. But we want to maintain a temperature, so I have to mention here, when we took water in measuring cylinder, we'll heat the water to 40 degrees and maintain the temperature. So this is how we work out how much salt dissolved in 100 cm cube of solvent. The last one is from winter 2018. Propanol and ethyl ethanoate are both solvent which can be used to remove the paint. We have to plan an investigation to determine which of these two solvents better to use to remove paint. You are provided with a glass slide, paint, two solvents are there. So what we will do in this one, first we'll apply the paint, equal amount of thickness or a coating of a paint on the glass slide, and then we will add equal amount of solvents and leave it for some time. And then after removing the solvent from it, we'll measure how much or what mass or what size of a paint or how much coating is being removed. This is one way. Or the second way, you will take equal amount, like you will apply paint on two different slides and add solvent until the paint is completely removed. The one which required a smaller quantity of a solvent to remove the paint, it means that is better to use. So we'll apply paint on two different slides. Then we will add solvent by the help of dropper, and we'll measure how much the volume of a solvent needed to remove the paint completely. Then we'll repeat with other solvent, and how we'll compare? We'll compare the volume of solvent needed to remove the paint. The experiment which require small quantity or small volume of the solvent to remove the paint is more effective. That's how we work out which of the solvent, either propanol or ethyl ethanoate, is better to remove the paint. So these are the last questions, experiment questions from 2018 session.